Hey Guy, today we're diving into a history of the stars. This journey takes you from the very first moment humans looked up at the sky to the wondrous discoveries made through telescopes and our dreams of travelling beyond the solar system. It's a voyage of light and memory. Each star reveals new cosmic secrets and reminds us that we too are forged from stardust. And when those celestial lights finally fade, what remains is the power of storytelling and remembrance, the undying light of humanity. Be sure to listen through the entire story to learn more. If you enjoyed it, please like, share, and subscribe to the channel for even more captivating tales. Chapter 1. When humanity first gazed upward. No one knows who was the very first to look up at the sky. No one remembers the eyes that first lifted toward the heights, where the dark vault above opened up, filled with countless tiny lights that later generations would call stars. They did not record it. They had no paper, no language, not even the notion of recording. But they had eyes, they had wonder, and they had time, plenty of time, to stare into the night. On the vast open plains where only the wind and the footsteps of animals could be heard, early humans lived amid the boundless wild. There were no houses, no electricity, no walls to block the light. Only darkness and the silent gleam of pinpricks high above. They did not call them stars. There was no concept, no word, only awareness that whenever the sun dipped below the horizon, those lights would appear. They did not run away, nor fade swiftly. They were there, night after night, as if watching. Early people had neither rulers nor clocks, yet they began to notice patterns. Some points of light seemed to move, some clusters held their shape, some stars vanished only to reappear. Something in the heavens pulsed, repeated, like the breath of an invisible creature. When the first fires were kindled, when ancient humans learned to cook and burn wood for light, the stars came to be seen as a distant fire, light that never went out. They believed them to be souls. They believed them to be the eyes of ancestors, of gods, of giant birds perched at the edge of the world. In the valleys that would one day be called Mesopotamia, the Sumerians etched the earliest signs of astronomy into clay tablets. They sketched constellations in wedge-shaped marks and called them gods of the sky. They observed not only in awe, but to foretell harvests, floods, death and life. The Egyptians too looked upward. In the deep desert night when the wind swept over the sands, they noticed a star rising just as the Nile began to swell. That star was Sirius, and from it they built their calendar. They split the year into 365 days, not for the love of round numbers, but because the heavens spoke. In China during the Shang and Zhou dynasties, the first astronomers sat through the night, charting the movements of stars on strips of bamboo and silk. They divided the sky into mansions, naming constellations after animals, plants and weapons. These records serve not just to marvel at the heavens, but to rule. For the Chinese emperor was the son of heaven, and any change in the sky was an omen. On nights like these, by the banks of the Ganges, Indian sages chanted under the stars. They logged planetary cycles, auspicious days, believing that the stars embodied karma, rebirth, and liberation. Each star's position corresponded to a life, a fate. In the lands later called Greece, lovers of reason, Thales, Pythagoras, began to ask, why don't the stars fall? Where are they? What are they made of? Gradually philosophy met astronomy. Thought met the sky. They built models of the cosmos, first with Earth at the centre, stars on revolving spheres. Then Aristarchus proposed that the sun lay at the centre. Millennia before that idea would be embraced. They drew circles and orbits, using mathematics to decode the heavens. No longer sacred mysteries, but the logic of the universe. Yet perhaps what never faded, from the ancient hunter to the Greek philosopher, was the feeling that the stars were gazing back at us. When children look up, they do not think of gravity. When a sentry on watch looks upward, he does not think in light years. When lovers sit in silence beneath the heavens, they do not calculate coordinates. They simply feel small, and at the same time, part of something greater than themselves. Across many cultures, the soul after death was said to become a star. From the tribes of North America to the peoples of Africa, from Norse myths to Aboriginal dreamtime, the idea that each of us is a star endures. In the sky reside parents, ancestors, the child who grows never old, the traveller who never returns. Perhaps that is why humans never stop looking up. Wherever they live, in whatever age, whatever skin, they have all looked skyward and asked the same questions. Whence did we come? Are we alone? Is someone looking back? In the stillness of the deep night, nothing soothes the soul like gazing at the stars, points of light that demand no answers, yet remain eternal questions. And so history begins, not with writing, not with weapons, but with a glance upward, a look that has lasted tens of thousands of years. After becoming accustomed to the light of the stars, humanity no longer observed them simply as part of the night. They began to notice that those points of light appeared in a definite order. Some stars rose at the same time each evening. Some shone only in certain seasons. Some moved slowly across the fixed backdrop of other stars. And then a question arose. If they always returned in the same way, might we map the sky? Thus the very first drawings were born, not with ink or pen, but with sticks tracing lines in the earth, with fingers on sand, with flint knives carving into animal bone. Later came clay tablets, papyrus scrolls, fine silk, and endless rolls of parchment. In Mesopotamia, where the Tigris and Euphrates rivers intertwined amid the dust of early civilizations, the Babylonians were the first to leave behind star maps legible to us today. They not only named the constellations, they recorded the motions of planets like Venus, Jupiter, and Mars. They tracked them for decades, patient and meticulous as stonecutters polishing each brick. Whenever a star rose later than usual, or a planet shifted direction, they noted it down. To them, these were more than physical phenomena. They were omens. The sky was a sacred book and the priests its readers. They believed that understanding the motion of the heavens revealed the will of the gods, and that grasping divine intent meant controlling human fate. The Egyptians were different. They didn't need detailed star charts. They needed precise timing. Every year, when the star Sirius, whom they called Sopdet, appeared just before dawn, the Nile would flood, bringing fertile silt. Missing that moment jeopardized the harvest. Egyptian astronomers were also priests of the calendar, guarding time as jealously as pyramid secrets. In ancient China, sky watchers sat in high towers, recording stellar movements with pictographic symbols. They didn't just redraw each constellation, they divided the heavens into 28 mansions, correlating to the moon's monthly journey. Each mansion represented a direction, a season, an element of the 5 phases. Any change, a star's disappearance or a strange light, was reported straight to the emperor, not for wonder, but for governance. In Greece, where philosophy met nature, scholars began to create maps that did more than record the sky, they explained it. They grouped stars into constellations, linking them into shapes of heroes, beasts and monsters from myth. They named them Orion the Unending Hunter, Andromeda the chained princess, Perseus the slayer of Medusa. Constellations became stories written in light. When a sailor left port, he read the stars not just to navigate, but to find his own tale in the sky. In the 2nd century, Ptolemy of Alexandria compiled the Almagest, cataloguing over 1,000 stars and defining 48 principal constellations, a system whose names we still use today. Though he erred in placing Earth at the universe's centre, Ptolemy gave astronomy its first systematic science, replete with tools and methods. In the southern hemisphere, the Polynesians, dwelling on tiny ocean isles, had no paper, telescopes, or calendars, but they possessed prodigious memory. They recalled star positions, rising times, and angles to the horizon. By these mental star charts, they voyaged thousands of miles of open sea in outrigger canoes, guided solely by light. Mapping the heavens is a profoundly human act, an innate need to order chaos, to turn the ungraspable into the nameable. Stars forever shift, yet a star map makes us feel we can comprehend the universe. For the first time, we were not merely hearing the sky's stories, we began to write them ourselves. When a child dots circles on paper, scribbles lines, and says, "This is a star," that act is no different from astronomers sketching the heavens with math and telescopes. All proclaim, "I see, I remember, I understand, if only a little." When humans began to leave their familiar lands, crossing rivers, forging through forests, venturing ever closer to the horizon, the stars came to journey with them. On the seas without landmarks, where sky and ocean melted into endless black, the light of the stars was the only constant. That was when the stars became true instruments of navigation. Not metaphorically, but in a concrete, essential, and precise way. The Phoenicians, masters of Mediterranean seafaring, were the first known to use the stars to orient themselves at sea. They watched Polaris, the North Star, because it holds a nearly fixed position in the sky, always pointing north. While other stars circle around it through the night, Polaris remains like a nail driven into the vault of heaven. By finding Polaris, a sailor knew at once which way was north. Thus they could sail from land to land without maps or compasses. Only a night sky and faith in its light. In the Pacific, Polynesian navigators, from Hawaii to New Zealand, used an even more complex system. They memorized hundreds of guiding stars. Each star rose from a different point on the horizon, and in each season, particular star groups pointed the way to specific islands. A ship's captain carried no paper chart. Instead, he held in his mind a living map woven of starlight, of wind direction, of the ocean's hues, and of ancestral tales. This knowledge existed only in memory, song, and ritual, never written, yet exact to every detail. In the north, the Vikings too relied on starlight. On voyages to Iceland, Greenland, and even North America, they navigated by the sun by day and the constellations by night. Though they left no detailed astronomical records, their settlements in distant lands attest to their ability to read the heavens. But the stars were more than a compass. They were symbols of hope, of yearning, of the unknown. In many cultures, a star was the gateway between life and death. When someone died, people looked skyward and said, "He has gone to the stars." This was more than a gentle turn of phrase. It was genuine belief that the sky held not only light, but memory, soul, and continuity. To the Maya, stars and planets embodied gods in an eternal cycle of rebirth and destruction. They built temples aligned with stellar positions. Each temple peak and passage was designed so that starlight would strike at a precise moment: birthdays, death days, dark moons or eclipses. For the Inca, the Milky Way, Mayu, was the heavenly river mirroring the sacred Vilcanota River winding through the Andes. In their belief, stars were shapes, camelids, foxes, serpents, formed by the dark spaces between them. They saw images in the void, as though nature spoke through emptiness. In medieval Europe, under the sway of religion, stars were proof of divine order. Church ceilings were painted with thousands of golden stars. Angels were thought to fly among the constellations. Comets, when they appeared, heralded either catastrophe or miracle. During that era, astronomers also began crafting the first instruments to see more clearly: astrolabes, sighting rules, observation towers, small steps on the long road toward observatories, telescopes and satellites. But before technology arrived, the stars were art's muse. From Homer to Shakespeare, from Haydn's symphonies to Van Gogh's paintings, starlight has summoned timeless emotion. Nothing is as simple as a point of light. Nothing as profound as that light piercing the darkness. The stars make us ask questions. More than that, they give us courage to live without answers, to embrace the vastness of the unknown. When Galileo first peered through his telescope and saw thousands of unnamed stars, he did not feel empowered, he felt diminished. And in that realization, he truly lived. From the pinpricks on prehistoric cave ceilings to the focal points of our space stations, the stars have accompanied us through every era. They are memory, compass, story, philosophy, music, faith. They are our mirror, reflecting us from a place far away, beyond, brighter still. And when we lie down, our eyes closing, suspended in silence, our breath slowing, even then the starlight remains, as it has for millennia, as in an unending dream. Chapter 2. When humanity began to measure time and distance by light. For thousands of years, starlight was seen as a sacred presence, the whisper of the cosmos, the gaze of the divine. The stories suspended overhead. People watched that light, memorized its patterns, connected its points into shapes, navigated by it, even prayed to it. Yet light remained just light, a symbol, a phenomenon. Until a simple but profound question was posed: what does that light really contain? This question did not emerge on a moonlit night, nor from a poet or a sailor. It arose in a small chamber filled with magnifying glasses, manuscripts and curious instruments. It was the era when scientists, from Galileo and Newton to Herschel, began to suspect that light was more than what met the eye. It could be analysed. In the 17th century, Isaac Newton performed a curious experiment. He passed sunlight through a triangular glass prism and saw white light split into 7 bands of colour: red, orange, yellow, green, blue, indigo, violet. No longer merely wondrous, it was the first sign that light had structure. If sunlight could be refracted into colours, so too could starlight. And if each hue corresponded to a wave, then light was a stream of data coursing through space. But at that time, no one knew what information it carried. That changed when the German astronomer Joseph von Fraunhofer, in the early 19th century, examined sunlight through a spectroscope. He saw something unseen before: dark lines, tiny cuts, across the rainbow of colours. They were not random, they followed precise patterns. They were the fingerprints of elements. Later, scientists discovered that each chemical element, hydrogen, helium, sodium, iron, when heated emits light with its own characteristic pattern of lines. By passing a star's light through a prism and recording those lines, one could determine exactly which elements the star contained. No one had imagined that, from Earth, by simply observing light, humanity could taste the chemical makeup of an object hundreds of light years away, the world suddenly grew richer. Not just a sky full of stars, but vast cosmic laboratories burning softly in space. Each star a reactor sending out encoded information about itself. Thus, light, once viewed as soul, became raw data. When astronomers like Annie Jump Cannon and Cecilia Payne began classifying stellar spectra in the early 20th century, they found the astonishing truth. Most stars share nearly identical compositions, overwhelmingly hydrogen and helium. Despite differences in colour, size and brightness, their physical natures were remarkably uniform. From this emerged a new idea. Stars are not unique creatures, but variations on a single process, the stellar life cycle. Stars are born, stars age, stars die. All follow physical laws, describable by equations and thermal curves, no longer immortal souls, but colossal gas spheres collapsing and exploding in well-defined stages. Light from then on not only revealed what a star was made of, but also what stage of life it occupied. Newborn, in full blaze, or nearing collapse. By measuring wavelength, intensity and spectral shifts, one could read a star's destiny, like the mood in a song. Light told us something else, something that changed everything. In 1929, astronomer Edwin Hubble observed distant galaxies and discovered their light was redshifted, meaning they are moving away from us. Not just a few, but all of them. The universe is not static, it is expanding. And if it expands, it must once have been smaller, originating from a single point. This insight led to the Big Bang theory, that the universe began in a tremendous explosion some 10 billion years ago. How did we know? From light. A beam travelling across space and time slithers into a tiny telescope, touching the lens of a solitary observer on a modest planet in an unremarkable star system. That light speaks softly. It does not shout or crash. It simply carries everything that ever was, if only you know how to read it. Like an unsigned letter sent from the past to the present. Like the echo of a primordial dawn that never fully fades. For generations, humans measured the world through what they could touch and feel, by footsteps, by the turning of the sun, by echoes in a cave. To gauge distance, they compared objects, a field beyond a hill, an island faintly visible on the horizon. But when they looked up at the stars and tried to measure the space between themselves and one of those distant lights, every familiar notion failed. How do you measure the distance to something you cannot touch, cannot travel to, and that seems not to move at all during a human lifetime? Then came a simple, yet powerful idea. Use light to measure light. Light, as humans discovered, not only carries information, it has speed. And unlike everything else in nature, the speed of light is constant. 458 meters per second in a vacuum. No faster, no slower. Unchanged by the observer. Once people understood that light could be used as a unit of measurement, they unlocked an entirely new scale, not in meters, kilometers, or miles, but in light years. A light year is the distance light travels in 1 year, about 9.46 trillion kilometers. A number too vast to imagine, but the only meaningful way to speak of the distances between stars, galaxies, and the edges of the universe. When you look up at a star 10 light years away, you're seeing light that left that star 10 years ago. You're looking into the past. The night sky is not a view of the present. It is a layered recording of time. Through telescopes, scientists observe galaxies hundreds of millions, even billions of light years away. Each glimpse is not just farther but deeper, like looking backward through the history of the cosmos. Light from those galaxies tells stories from before Earth was formed, before oceans existed, before trees, before humans. The sky becomes a vault of memory, stretching endlessly. But measuring distance by light is not just a philosophical idea, it is the foundation of all modern astronomy. And to measure, humans needed a reference point, a baseline. They began with parallax, observing a nearby star from two different positions in Earth's orbit around the Sun, then measuring the tiny shift in angle against the background of distant stars. From that, they could calculate the star's distance. But for stars farther away, parallax becomes ineffective. The angle's too small to detect. That's when astronomers turn to standard candles, celestial objects whose true brightness is known. By comparing their observed brightness to their intrinsic brightness, they could estimate distance. One of the most important of these candles is the Cepheid variable star, a type of star that pulses with a predictable rhythm. Henrietta Swan Leavitt, a quiet astronomer working at the Harvard Observatory in the early 20th century, discovered that the period of a Cepheid's pulsation is directly related to its actual brightness. Once you observe a Cepheid, you can calculate how bright it truly is, and thus, how far away it must be. Using Cepheids, in 1923, Edwin Hubble measured the distance to the Andromeda Galaxy, the closest large galaxy to our own. What he found shook the world. Andromeda was not inside the Milky Way. It was a separate galaxy. This meant the universe didn't contain just one galaxy, but countless. An idea once thought impossible, that the night sky isn't a decorative dome over Earth, but a boundless cosmos filled with hundreds of billions of galaxies, each with hundreds of billions of stars, and all of it can be measured, using only light. As modern observatories were built, like Palomar in California or La Silla in Chile, humans no longer look skyward with just their eyes, but with ultra-sensitive cameras, giant mirrors, and sensors capable of detecting even the faintest glimmer in the dark. They timed light. They recorded star pulsations. They analysed colour and spectral shifts. Everything once symbolic now became numerical, precise, repeatable, calculable. And from this, something inevitable followed. Humanity began to relocate itself within the cosmos. We were no longer the centre, no longer the focal point of the heavens, no longer the destination of the star's light. We are a speck, orbiting an ordinary star, on the outer arm of a spiral galaxy filled with hundreds of billions of stars, itself one among hundreds of billions of galaxies, in a universe that is expanding and slowly cooling. Everything we know, our history, poetry, wars, love, death, fits on a pale dot suspended in ancient light. And yet, remarkably, from that speck a small creature looked up, measured, and wrote it all down, using a light that was never meant for anyone. There comes a moment when science ceases to be a tool, ceases to be mere curiosity, and becomes a mirror. A strange mirror, one that does not reflect outward appearances, but reflects our deepest origins. That moment arrived when humanity asked a deceptively simple question. If stars are only made of gas and energy, then where did everything around us, rock, tree, water, the human body, come from? The answer lies within the very light of the stars, in the spectra we've analysed, in the dark lines crossing the rainbow. From this, we learned that stars are not just glowing balls of gas, they are forges of elements. It begins with hydrogen, the simplest atom, with one proton and one electron. Within a star's core, where pressure and temperature reach unimaginable extremes, hydrogen atoms collide and fuse into helium. With each fusion, a portion of mass is converted into energy, released as light, the very light we see from Earth. But the story doesn't end with helium. As a star ages, it continues to fuse heavier elements, carbon, then oxygen, neon, silicon, until it reaches iron, the final threshold of energy-producing fusion in stars. At that point, if the star is massive enough, it can no longer support its own weight. It collapses. And in that collapse comes an explosion, a supernova, releasing an immense burst of energy in just seconds. Only in such explosions are heavier elements, gold, silver, lead, uranium, born. These particles, carbon, calcium, iron, gold, are flung into space, drifting outward, settling, merging into nebulae, into new clouds of gas and dust. From those clouds, new stars are born, new planets take shape, new bodies are formed. That physical process led to a startling realization. Something that, had it been said just a few centuries ago, would have been dismissed as fantasy. Your body, from bones, blood and cells to your breath, is made of the dust of dead stars. The iron in your blood once resided in the heart of a giant star. The calcium in your bones was formed in the death throes of a supernova. The carbon in your DNA, in your brain, in the very touch of your hand, can all be traced back to a cosmic fire, billions of years ago, in a place whose light is only now reaching Earth. When astronomer Carl Sagan said, "We are made of star stuff," he wasn't speaking metaphorically. He was stating a scientific truth, a truth that is warm, a truth that is lonely. The sky is not just something we look up to, it is where we came from. We are not tiny creatures adrift in a cold, indifferent cosmos. We are the cosmos itself, matter that once drifted nameless and formless through billions of years, then gathered, organised itself, lived thought, and looked back toward the place from which it came. In a very real sense, when you gaze at a star, you are not looking at something foreign. You are looking at an ancient part of yourself, a part that existed before Earth was born, a part that will continue long after we are gone. And so stars evolved, from divine symbols to data, from data to tools of measurement. And in the end, from tools, they returned to being mirrors of the soul. Stardust made us. And Starlight, with its billion-year-old messages, reminds us that we are not alone in the universe. We are a part of it, not lost among the stars, but a star ourselves, living among our cosmic kin, breathing with oxygen, thinking with carbon, writing with electrons, and quietly returning to dust as time moves on. Chapter 3. When humanity's eyes and ears were sent to the sky. Since the first time humans learned to shape stone into tools, to raise stone pillars marking the seasons, or to etch star paths onto clay tablets, the goal has never changed. To see more clearly, to hear more deeply, to understand the sky more intimately. But Earth, this small deep blue planet, is not an easy place for such aspirations. The atmosphere, which protects life from cosmic radiation, is also the veil that blurs the pure light of stars. It distorts images, causes distant points of light to flicker, and blocks nearly all radio waves, gamma rays and X-rays, types of signals that carry vital information from the most mysterious objects in space. Until one day, humanity realised, to truly see the stars, we must leave the ground. In the early 20th century, when aviation had barely begun, no one imagined that just a few decades later, machines would not only fly, but escape Earth's gravity entirely. Yet, with the advancement of rocket science, the impossible became reality. In 1957, the Soviet Union launched Sputnik 1, the first artificial satellite. It wasn't a telescope, carried no lenses or starlight sensors, just a small metal sphere with a radio transmitter. But it made one thing clear. Humanity had begun placing instruments into space. Just over a decade later, in 1970, the first space-based observatory, Uhuru, was launched. Instead of visible light, it listened to the universe in X-rays, a form of energy emitted by cataclysmic events like black holes, neutron stars, and supernovae. With Uhuru, humankind for the first time heard the invisible voices of the cosmos. From that point forward, a wave of space-based observatories was born. And then came a name that would become iconic, the Hubble Space Telescope. Hubble was not the first telescope, nor the most powerful by modern standards. But when it was placed in orbit in 1990, it carried with it a dream never before realised, to see the sky without a single cloud in the way. Orbiting about 547 kilometres above Earth, Hubble floated in silence, capturing images of the universe. No flicker, no blur, no distortion. And in one of its most famous images, the Hubble Deep Field, scientists pointed it at what seemed to be a completely empty patch of sky, no bigger than the head of a pin held at arm's length. The telescope photographed continuously for several days. When the image was processed, no one could believe it. In that tiny patch of nothing, there were thousands of galaxies, each containing billions of stars. A sliver of the sky, barely larger than a thumbnail, held up to the dark, held an entire universe. From that moment, Hubble ceased to be just a camera. It became a mirror of existence, reflecting how vast the cosmos truly is. Every one of its images a quiet reminder. We are only a small part, but we are able to see the whole. Not only did we learn to see visible light, we learned to listen to the cosmos through radio waves. From the mid-20th century onward, radio observatories like Arecibo, Parkes and Very Large Array rose like giant ears turned toward the sky. They didn't see, they listened. And in that cosmic soundscape came the steady pulses of pulsars, rapidly rotating neutron stars beaming out radio waves like celestial clocks. They also detected the faint echoes of the cosmic microwave background, the leftover radiation from the Big Bang. Thanks to these listening devices, humanity discovered for the first time that the universe is not silent. It hums and murmurs, telling its story through frequencies, static, and mysterious bursts from galaxies billions of light years away. And recently, even gravity has found its voice. In 2010 in Gifimini, the LIGO Observatory detected gravitational waves for the first time, ripples in the fabric of space-time caused by the collision of two black holes, a collision that happened over 1 billion years ago, but whose aftershock, smaller than the width of an atom, was still detectable on Earth. As if the universe doesn't only shine and whisper, it trembles when something immense occurs. Today, as we place the James Webb Space Telescope in orbit, with its massive golden mirror designed to peer at the very first stars, or send Voyager probes beyond the edge of the solar system, our journey is no longer a dream. It is reality. We have sent our eyes and ears into space, among the stars, to watch for us, to listen for us, and to tell us what they find. No one knows how many mysteries still drift silently over our heads each night, but we do know this. Even as Earth spins and time flows forward, those instruments continue their quiet work, patient, tireless, unwavering. Because since that moment, the sky is no longer just something we gaze at. It is something we now live alongside, learn from, and move steadily toward. Since the first time we looked up at the sky, humanity has asked, are we alone? Beneath thatched roofs in the Stone Age, at the altars of Egyptian temples, through Galileo's bronze telescope, or reflected in the golden mirror of the James Webb Space Telescope. That question has never changed. But only recently have we gained the tools to seek a scientific answer. Because to know if life exists out there, we must ask, are there any other planets? Before the 20th century, that question remained a matter of speculation. Astronomers could only observe stars, distant suns, but not the planets that might orbit them. The star's brightness overwhelmed anything faint nearby. A planet, emitting no light of its own and only reflecting, was completely swallowed in that brilliance. So scientists shifted their approach. If they couldn't see a planet, they would look for its effect. And thus the Doppler shift method was born, detecting tiny wobbles in a star's motion caused by the gravitational tug of an orbiting planet. The movement was minuscule, nearly imperceptible, but measurable through spectral analysis. In 1995, Michel Mayor and Didier Queloz used this method to discover 51 Pegasi b, the first confirmed exoplanet orbiting a sun-like star. That moment reshaped modern astronomy. We no longer had to assume planets exist, out there, in great numbers. From that point forward, the hunt for exoplanets, planets beyond our solar system, entered an explosive phase, and the key tool became the transit method. When a planet passes in front of its host star, Even if it covers only a tiny portion, ultra-sensitive telescopes like Kepler and TESS can detect the slight dip in brightness. From that, astronomers know a planet has passed by. Measure how often it repeats, and you get the orbital period. Measure how much light is blocked, and you learn the size. Combine with stellar data, and you can estimate surface temperature. Each new planet is discovered not by direct sight, but by trace, like specks of dust that appear when light hits at the right angle. And as the list grew, thousands, then tens of thousands, scientists began to filter them. Is there a planet like Earth? Meaning, not too close to its star, where it would burn. Not too far, where it would freeze. In the habitable zone, where liquid water could exist. With moderate size, rocky composition, not gas giants like Jupiter. With an atmosphere, with a stable rotation, with a clear orbital cycle, and gradually names began to appear. Kepler 452b, Proxima Centauri, b, TRAPPIST 1e, LHS 1140b. Each one a hope, an unverified possibility, but enough to make an entire generation lift its eyes higher toward the sky. Because if distant suns have planets, those planets might have skies. And perhaps under those skies, someone is asking the same question we are. But humanity didn't stop at planetary shapes. We began to look for the light of life. Though we cannot send probes to these distant worlds, we can analyse the light that passes through their atmospheres. When a planet transits its star, the starlight that filters through its atmosphere carries the signature of molecules: water vapour, methane, oxygen, carbon dioxide. These are biosignatures, chemical fingerprints that could point to life now or long ago. Just as ancient people read animal tracks in the sand, modern astronomers read light spectra for signs of a silent biosphere breathing across the light years. And if one day that light contains a pattern of gases like Earth's, then we may no longer be alone. We do not yet know if anyone is out there. But the act of searching, despite no answer, already reveals so much about ourselves. We search because we want to understand who we are. We look up because we were born from up there. We measure, analyse and record because we are conscious dust asking about our origins. Maybe no one will reply. Or maybe the light that answers is already on its way, is already on. Since ancient times, humans have prayed to the stars. They whispered names of constellations in the season of ripening rice, sent their wishes into the sky, composed poems for the night's glow. But those prayers vanished into the wind, into time, carrying nothing tangible but hope. Only when we discovered electromagnetism, uncovered radio waves and built devices capable of transmitting information beyond Earth, did we begin to ask, if someone is out there, what could we say, and would they hear us? The 1970s, a remarkable era. The Cold War was still simmering, but in quiet observatories where scientists worked not for territory, but for the sky, a new idea was born: to send a greeting into space, not to anyone specific, but to anyone, anywhere. In 1972, Pioneer 10 was launched, flying past Jupiter and out of the solar system. Attached to its body was the Pioneer plaque, a gold anodized aluminum plate, about the size of a notebook, etched with acid. On it, the image of two nude human beings, a man and a woman, standing side by side, hand raised in greeting. Behind them, a diagram of the solar system, the spacecraft's trajectory, Earth's location, and pulsar signals, cosmic milestones. There were no words, no language, just images, like a letter written in the universal instinct of existence. We are here. This is what we look like. This is our home. After Pioneer came Voyager 1 and Voyager 2, spacecraft that travelled farther than any human creation ever had. Launched in 1977, they carried the golden record, a treasure of carefully curated sounds and images meant to tell the story of Earth. On that record, greetings in 55 languages, music from Bach, Beethoven, and Chuck Berry. The cry of a baby, thunder, a train, a heartbeat. Pictures of humans, animals, maps, DNA, cars, flowers, images of Earth, the small blue planet floating in the black. No one expected aliens to have a record player, but that wasn't the point. The point was, we spoke. Also in the 1970s, the Arecibo message was transmitted. On November 16, 1974, a powerful radio signal was beamed from the Arecibo telescope in Puerto Rico. It lasted less than 3 minutes, a binary message of 1,679 bits. Its content, a diagram of prime numbers, the atomic structure of DNA, the figure of a human, Earth's population at the time, the layout of the solar system, and the design of the telescope itself. The message was aimed at the M13 star cluster, about 25,000 light-years away. If anyone's there, and if they receive it, and if they have the technology to understand, they'll hear our hello in 25,000 years. And if they respond, it would take another 25,000 years to return. A 50,000-year conversation for just 2 sentences. It may sound absurd, but not every word needs a reply. Some things are spoken simply to be spoken, because if we didn't say them, we wouldn't be who we are. Like writing someone's name in sand, knowing the waves will wash it away. Like placing a hand on your chest and whispering into the night, I am still here. Sending signals into space is the same. A declaration of existence, not for aliens, but for ourselves. Even today, such signals continue to be sent. From radio telescopes, from satellites, from projects like Breakthrough Message or METI. They may be encoded, designed for clarity, even artistic, but they all carry the same core message. We are searching. We are listening. We are alive. At the same time, we also listen. Radio observatories like FAST in China, Green Bank in the US, and the VLBI network sweep the skies, recording every strange signal, every untraceable wave. So far, there has been no reply, but we do not stop, because sometimes listening matters more than the answer. Maybe out there, someone else is also transmitting. A plaque, a song, a heartbeat. Like us, they just want to be known, not to invade, not to conquer, but simply to connect. And if one day, amid the endless cosmic static, we detect a pattern of numbers, a meaningful structure, a greeting in a language never heard before, that will be the first time we truly hear the voice of the stars. Not light, not images, but another consciousness, from somewhere far away, reaching out to us. And in that moment, the history of the stars will gain a new chapter, one written together. Chapter 4, when the dream of living among the stars began. Perhaps from the very first moment a human saw a shooting star streak across the night sky, the dream was kindled. A dream of leaving the ground, breaking through the atmosphere, and standing on another world, watching Earth grow small and vanish into the distance. Though once a vague idea, it never faded with time. On the contrary, the more we learned about the universe, about planets, about our limits and our fragility, the more it became clear. This dream was not a luxury. It was a necessity, not just to explore, but to survive. When Neil Armstrong set foot on the moon in 1969, the entire world held its breath. One small step for a man, one giant leap for mankind. It was only about 384,000 kilometers away, a few days' journey, but the moon marked the first milestone that showed we can leave our homeworld. From that moment on, the question was no longer, can we leave Earth? But, can we live somewhere else? At first, the answers came in the form of simple maps. Mars, with its red skies and polar ice. The moons of Jupiter, like Europa, its thick ice shell hiding a vast subsurface ocean. Titan, Saturn's moon, with an atmosphere, methane lakes and gentle rains. These places, cold, toxic, distant, somehow held a strange kind of promise, as if they were saying, "I am not Earth, but you may try." And so began the era of design, not of fantasy, but of engineering. Scientists drafted concepts for moon habitats, dome structures shielded from radiation, using underground water as natural protection. Designs for greenhouses on Mars were proposed, growing vegetables in sealed environments, recycling air, converting CO2 into oxygen via electrolysis. Many dismissed these as delusions, but every first dream of flying, of crossing oceans, was once called madness. Alongside the technical research, a quieter question emerged. Why do we need to live elsewhere? Part of the answer is curiosity, but deeper still, it's because Earth is not forever. Our planet, beautiful and alive, is not immune to danger, natural disasters, climate change, environmental degradation, and beyond that, cosmic threats like asteroid impacts, solar storms, or simply time. The sun, our life-giving star, will not burn forever. In about 5 billion years it will expand, engulfing the inner planets. Earth, with its cities, memories and legacies, will vanish like it never existed. That's why the idea of living among the stars is no longer optional. It's becoming a long-term survival strategy. Just as fish once crawled from oceans to land. Just as our ancestors left the savannah to build cities, now their descendants speak of leaving the planet, to continue writing the story of humanity. Someone once said, "Humans are the way the universe becomes aware of itself." So if consciousness can spread, if knowledge can be carried, if human eyes can gaze upon other skies, then living among the stars is not just survival, it is an obligation, a promise to history. We will not end where we began. Today, private companies like SpaceX, Blue Origin, and agencies like NASA, ESA, JAXA are preparing for what is no longer a dream, to establish long-term presence on the moon, to set foot on Mars, and beyond that, to find habitable worlds beyond the solar system. We are standing at the edge of a new age, an age where our address is no longer just Earth, but might soon be Alpha Habitat, the Moon, Mining Station 4B, Europa Orbit, or even Biodome 2, Kepler 452b, Cygnus System. Perhaps we won't live long enough to see that day, but in every test tube, every rocket, every greenhouse blueprint for Mars, there lives the dream of millions of years spent looking up. And in the future, if a child is born on a world without blue skies, without oceans, but one night sits by the window of a biology station, gazing at a tiny light in the distance and asks, "Did anyone ever live there?" then that light shining from Earth will be the answer. Long before we had rockets, satellites, the periodic table, or the Big Bang Theory, the stars lived in the human mind. Not as physical objects, but as symbols, as figures, as worlds unseen yet vividly told through stories. From those stories, imagination reached far beyond the telescope. It created planets that never needed to exist in reality, because they were real in the soul. The mythologies of ancient civilizations were the first cosmic maps of human imagination. In the sky, the Greeks didn't see scattered points of light. They saw Orion, the brave hunter. They saw Andromeda, the chained princess. They saw beasts, heroes, tragedies, suspended against the sky. In ancient China, the heavens were divided into star regions, each corresponding to a piece of the empire below. Each constellation stood for an official, a mythical creature, an element of the 5 phases. Heaven and earth mirrored one another, as if culture was a reflection of the cosmos. From early on, humans understood, even if we cannot touch the stars, we can assign them meaning. When literature emerged, planets became the backdrop for dreams and foreboding. In the 17th century, French writer Cyrano de Bergerac imagined travelling to the moon, not by machinery, but by boiling water, springs and flat mirrors. A naive, yet poetic vision. His novel L'Autre Monde was among the first to frame planets as places not just to gaze upon, but to live on. By the 19th century, authors like Jules Verne, From the Earth to the Moon, and H.G. Wells, The War of the Worlds, turned planets like the Moon and Mars into dramatic stages, where human intellect collided with the mysteries of the universe, and with its own fears. In those pages, Mars was no longer just a red planet. It was the invader, the other, the non-human, the dark side of ourselves. The Moon wasn't just a satellite. It became the first step beyond our limits, a place of hope and trial. In the 20th century, as humans truly ventured into space, imagination didn't fall behind. It raced ahead of the rockets. In novels, films, music, and art, stars and planets became characters, symbols of longing and aspiration. From Star Trek to Star Wars, from 2001, A Space Odyssey to Interstellar, from David Bowie's Starman to the space anthems of Vangelis, space was no longer empty. It became the stage for our deepest stories. Love, life, death, time, memory. The universe in culture is never cold. It is intensely human. Because when we step into space through imagination, we bring everything with us. Our memories, our hopes, our fears, and our nameless questions. And when writers began naming planets that didn't exist, Arrakis, Krypton, Pandora, we understood something. The stars were no longer distant. They had become mirrors reflecting the moods of our time. When the world feels suffocating, we write of ruined worlds. When people feel lost, we write of lonely wanderers between galaxies. When science advances, we imagine interstellar empires. When war looms, planets become refugees. When religion questions life's meaning, they become crucibles of faith. Every fictional planet is a corner of the human mind, lit not by photons but by words and music. And then strangely, as science progressed, imagination had already gone ahead. We once dreamed of a planet covered in oceans, and then we found one. We imagined worlds with 2 suns, and then discovered Kepler 16b. We wrote about creatures living in subsurface oceans, and Europa and Enceladus began to reveal the same possibility, as if imagination blazed the trail, and science followed, slower, more cautious, but faithful. And perhaps in the end, what makes humanity special is not that we can reach other planets, but that even before setting foot there, we've already lived there, in spirit. The stars are something scientists wait to measure, but they are also what poets are still writing the final line about. Earth was once everything. Then the Moon became the first step. Mars became the next target. And after that, humanity began to look farther, past the cold orbits of the giant planets, beyond the icy bodies of the Kuiper Belt, past the edge of the solar wind. There, where the sun's influence fades, where no sunlight can illuminate the back of a spacecraft, begins a true darkness, the space between stars. For a long time, the distance between stars was seen as insurmountable. The closest, Proxima Centauri, lies 4.24 light-years away, about 40 trillion kilometres. With today's technology, it would take tens of thousands of years to get there. It's so far that even a beam of light sent now wouldn't arrive for over 4 years. And yet, despite that, humanity dares to imagine leaving the solar system. Not because it is easy, but because the impossibility of it makes the dream worthwhile. In August 1977, Voyager 2 was launched, carrying the golden record, messages of peace, and scientific instruments. A month later, Voyager 1 followed. No crew, no plan to return. They were designed to keep going, past the giant planets, past the invisible boundary, into a darkness no one had ever entered. In 2012, Voyager 1 officially left the solar system. It entered interstellar space, beyond the reach of the sun's wind. No sirens, no signals, no light. Just a small machine, 7DP2, drifting silently through the dark, carrying the memory of an entire species. Nearly 50 years after leaving Earth, Voyager still functions, faintly, but still moving. It is our planet's first emissary, and it stands as a symbol of something irreversible. We have begun to leave our star. But Voyager isn't the end. It's only a quiet beginning. Over the past decades, scientists, engineers, and dreamers have envisioned going farther, faster, bolder. One of the most audacious projects is Breakthrough Starshot, introduced by the late physicist Stephen Hawking in 2016. The idea is simple yet revolutionary. Instead of launching traditional rockets, we build tiny spacecraft the size of a human hand, called starships, attach them to light sails, and fire high-powered lasers from Earth to propel them to 20% the speed of light. At that speed, a starship could reach Alpha Centauri in just 20 years. No crew, no reply expected. But if successful, it would be the first human-made object to reach another star system, a leap beyond imagination in the millions-year history of life on Earth. Other ambitious concepts exist. Nuclear pulse propulsion, using small nuclear explosions to push a ship forward, as envisioned in Project Orion in the 1950s. Antimatter engines, generating immense thrust from matter-antimatter annihilation. Theoretical Alcubierre drives, bending space-time itself to surf through space, surpassing the speed of light within the rules of general relativity. These ideas for now remain on paper, distant like science fiction. But so was flight once, and yet we flew. Leaving the solar system isn't just a matter of technology, it's a question of time, patience, and purpose. If a ship launched today and arrived 100 years from now, would anyone remember why it left? If a reply came from an alien civilization in 50,000 years, would anyone still be listening? And if one day, when the first humans step onto a planet beyond our solar system, no longer carrying our genes, our languages, or our memories, will they know that the dream began here? On the blue planet they never knew. That's why leaving the solar system is not the story of a single lifetime. It is the long vow of an entire species, a promise written in light, a journey without haste, but one that never stops. Maybe in the end we won't be the ones who arrive. Maybe those who do will no longer be human in the way we once defined it. But the destination is not what matters most. What matters is, we began. And we sent a message to the stars. We are coming. Chapter 5. When humanity began to realise the sky was not eternal. There was a time when humans believed the sky was the only constant. On Earth, everything changed. Seasons, trees, people, wars and ages. But when night fell, the stars were still there, unmoving, undying, unyielding. They were named carved into stone, drawn on clay tablets trusted as everlasting light. Even the word astronomy, from Latin roots, means the laws of the stars, a cosmic order that could not be broken. But then came telescopes, measurement became precise, and slowly a truth emerged. The sky is not immutable. Everything up there, no matter how bright or how silent, is born, changes, and dies. Can a star die? The question sounds strange. A star is light. It is brilliance. It is life. But that light is not endless. It is the product of energy, and energy, sooner or later, runs out. Inside every star, atoms collide, fuse, and release heat and light. This process lasts millions to billions of years, depending on the star's mass. But eventually the fuel, usually hydrogen, is exhausted. And that is when fate begins. Small stars, like our sun, after running out of hydrogen, swell into red giants, engulfing nearby planets, perhaps even Earth. After a time, they become unstable, shedding their outer layers into space, leaving behind a small, dense, hot core, a white dwarf. No more burning, no more energy, only the ashes of former light. Larger stars, 10 or more times the mass of the Sun, meet a more violent end. When their cores are filled with iron and fusion can no longer continue, they collapse. An implosion so rapid, it triggers a cataclysmic supernova. In mere seconds, the star outshines entire galaxies. Its matter is blasted outward, but its core collapses further until nothing can stop it. It becomes a black hole, a place where not even light can escape. A rupture in space-time, a darkness not from absence of light, but from the impossibility of light returning. Once these were only theories, but then we began to see them. Spacecraft recorded supernovae in distant galaxies. Radio telescopes detected pulsars, rapidly spinning neutron stars, ticking like cosmic clocks. Gravitational wave detectors registered the ripples of space-time from colliding black holes, vibrations spreading like waves across the universe. There was no longer any doubt. The universe is not still. And it's not just stars. Galaxies, once thought to be frozen in place, are rushing towards each other at hundreds of kilometers per second. Our own Milky Way is on a collision course with the Andromeda Galaxy, another spiral galaxy, 2.5 million light-years away. When they collide, about 4 billion years from now, the galaxies will twist, tangle and merge into one, not in a fiery crash but in a slow reordering of hundreds of billions of stars. Not an apocalypse, but not the sky we once knew. Humans once believed stars were immortal. Now we know. They age. They die. And the universe itself will die too. Modern cosmologists speak of a concept called the heat death of the universe. They believe the cosmos will continue expanding. Stars will burn out, and no new ones will form. Energy will thin out. Light will fade. And one day, trillions of years from now, everything will be cold, dark, and still. No more stars, no more movement, no more information. Only silence. It may sound sad, but in truth it is the first time we've realised that death is not just a human experience. It is a law of the cosmos, and that makes every burning star we see tonight precious. When you look at the night sky and see a twinkling star, you are witnessing a temporary moment in its long cycle. That light may come from a star that has already died, or one that is just about to fade, or one that will burn for billions more years, never knowing you looked at it. But that moment, when you saw it in the silence of night, is part of history, not human history, but the history of light, of change, of a universe that never stops transforming. Since the dawn of time, light was what humans trusted. When the sun rose, the day began. When a lamp was lit, the night grew less dark. When stars twinkled, we could navigate, mark time, even pray. Light seemed loyal. It travelled straight, spread out, carried information. We measured the universe by it. We measured distance in light years. Measured the universe's age through ancient light. But then modern science revealed something strange. Light does not always travel straight. It can be bent, pulled, even trapped. And that changed everything. In 1915, Albert Einstein completed his theory of general relativity, a model in which space and time are not separate, but together form a flexible fabric. Mass, especially massive objects, doesn't just sit in space, it bends it. Like a heavy ball placed on a rubber sheet, creating a dip around it. And when light passes through that curved space, it no longer travels in a straight line. Not because something blocks it, but because space itself is warped. This phenomenon is called gravitational lensing, and nature proved Einstein right. In 1919, during a total solar eclipse, astronomer Arthur Eddington measured the positions of stars near the edge of the sun and saw they had shifted slightly, as if their light had been bent by the sun's gravity. For the first time in history, humans saw light veer from its path, not because of a mirror or a wall, but because space itself had curved. From then on, telescopes began hunting for gravitational lensing across the cosmos, and they found wonders. Galaxies that appeared doubled or tripled. Not because they had twins, but because their light was bent around a foreground galaxy. Perfect circles of light, called Einstein rings, where light from a hidden object was curved evenly around another, like the universe wearing a glowing ring. Stars that flickered more brightly, momentarily magnified by an invisible gravitational lens. Like a magnifying glass held up to the sky, the universe, once thought simple, now appeared layered and twisted. A distorted mirror constantly reshaping itself. But light doesn't just bend. Near powerful gravitational fields, like those around black holes, light can be trapped. If it ventures too close beyond a boundary called the event horizon, it can no longer escape. Not because it's pulled, but because every path leads inward. A black hole, then, isn't black because it swallows light, but because light has no way out. No path back to tell us what lies inside. To ancient people, light was a symbol of life, knowledge, divinity. Now we know, light can also be lost, can be held, can fall silent. And strangely enough, this very truth gave us powerful tools. By measuring how light bends, we can detect dark matter, which emits no light, interacts with nothing, yet has gravity. By observing warped light, we find hidden objects, dim galaxies, medium black holes, even rogue planets drifting through darkness. By studying how light vanishes, we can map the very structure of space-time, drawing the contours of reality itself. Light, once simple, has become the most complex map humanity has ever tried to decode. And among all these mysteries, one of the strangest is this. Though light can bend, disappear, or wander, some light still finds its way back. When a star is devoured by a black hole, its gas forms an accretion disk, releasing dazzling X-rays, brighter than the star ever was. When two black holes collide, though they emit no light, they create gravitational waves, ripples we can now hear. When light is slowed by warped space, it arrives late. But it still arrives. As if the universe, vast, twisted, full of shadows, still finds a way to send light to us. So next time you look up at the night sky, remember, the light you see did not always take a straight path. It may have looped around a galaxy. It may have brushed the edge of a black hole. It may have taken millions of years to reach your eyes, but in the end, it reached you. And it carries the story of what cannot be seen. Every light you've ever seen in the sky comes from a star, a burning ball of hot gas that has blazed for millions or billions of years, suspended in the vastness of space. But not all light comes from stars. There is one kind of light that belongs to no star, not from the sun, not from a galaxy, not from any glowing planet. It comes from the universe itself, and it is the oldest light we have ever seen. This light has no brilliant colour. It doesn't twinkle. It doesn't sparkle. No one has ever seen it with their eyes. And yet it is always there, like a quiet background wave, spreading through space, seeping into every corner, gently, persistently, older than anything that has ever existed. It is called the cosmic background radiation, or more familiarly, the cosmic microwave background, CMB. What is the CMB? It is the first light, light from the universe's infancy, before stars, before planets, before galaxies, when the entire universe was a searing sea of plasma, hot and chaotic, where light was trapped by dense particles. But then as the universe expanded and cooled, around 380,000 years after the Big Bang, electrons began to combine with protons to form neutral atoms. At that moment, light was finally free to travel. And it began its journey, uninterrupted for 13.8 billion years, until it was caught by a small device on Earth. Strangely, the first people to discover the CMB weren't looking for it. In 1964, two engineers at Bell Labs, Arno Penzias and Robert Wilson, were testing a new radio antenna. They detected a strange background noise, faint, steady, coming from no specific direction. They tried everything, cleaned the equipment, chased pigeons from the antenna, rotated it, replaced parts. But the signal wouldn't go away. Only later did they realise they were hearing the echo of the Big Bang, a sound without sound, a light without image, a memory from the moment the universe first opened its eyes. The CMB isn't white. It doesn't burn hot. It is microwave radiation, with wavelengths longer than visible light, but detectable by special antennas. It has a very low temperature, around 2.725 Kelvin, just above absolute zero. And what makes it important is not its brightness, but its eerie uniformity. When satellites like COBE, WMAP, and later Planck scanned the sky, they recorded maps of the CMB and discovered that it covers the entire universe. It is nearly identical in every direction, but it has tiny, tiny ripples. Temperature variations just 1 part in 100,000, and those ripples became the seeds of galaxies, stars, planets, and us. Without those subtle lumps, the universe would never have clumped together. No stars, no light, no Earth, no one to look up and ask questions. Those invisible ripples were the embryos of everything, and there is something even stranger. The CMB is not just the first light, it is the baby picture of the universe. By measuring it, analysing its tiny fluctuations, scientists have been able to determine the universe's age, its rate of expansion, its matter content, even the presence of dark matter, and hints at the universe's fate. The CMB, faint echo from long ago, is the most detailed record of the beginning, as if the cosmos left us a silent, honest portrait of its infancy, and that light is still travelling. Right now, as you read these words, that ancient light is passing through you, through your skin, your home, your city, your planet. Not with destructive energy, but with quiet presence. Because this light never stops. It is the backdrop of all backdrops. It is the light of the beginning. And the oldest memory humankind has ever touched. None of us lived to see the Big Bang. But when you look up at the night sky, when you fall silent and wonder where you came from, when you ask, where did all this begin? Remember this. The answer is passing through you every second. It does not speak, it does not sing, but it remains. Quiet, eternal, burning brightly in silence. Chapter 6. When humanity began trying to recreate stars in the laboratory. If you've ever looked up at the night sky and seen a twinkling star, remember this. That light is the result of a mind-bendingly powerful physical process, happening relentlessly in the core of that star. Not fire like burning wood or glowing coal, not combustion with oxygen like in an oven, but nuclear fusion. A reaction where light atoms like hydrogen merge into heavier atoms like helium, and in the process release an enormous amount of energy. That is the fire of the stars. It's why you see the sun's light every day, and it's what led humanity to ask, if stars can do this, why can't we? Thus began a dream, not one found in poetry, but in the lab, to create a tiny star right here on Earth, not to admire, but to study, understand, and harness the most powerful clean energy source ever known. The first ideas of artificial fusion didn't come from peace. They began with bombs. In 1952, the United States tested the first hydrogen bomb, a thermonuclear bomb. Unlike atomic bombs, which split atoms apart, fission, thermonuclear bombs fuse light nuclei together, mirroring the process happening in stars. The result? An explosion dozens of times more powerful than a nuclear fission bomb. Fusion had proven its might, but it was uncontrollable. So by the mid-20th century, scientists shifted focus, not to create stars for destruction, but to nurture light. From there, the first fusion reactors were born, simple, fragile, sometimes failures. But each experiment brought us a step closer to recreating the sun's core on Earth. Fusion requires two things: extremely high temperatures, hundreds of millions of degrees Celsius, so that nuclei have enough energy to overcome their electric repulsion and merge, sufficient pressure or confinement time to allow the reaction to happen efficiently and remain stable, but no material on Earth can contain plasma that hot. So humanity invented superconducting magnets, creating magnetic bottles that suspend plasma mid-air, keeping it from touching the reactor walls. One of the most prominent designs is the Tokamak, a donut-shaped chamber where plasma swirls like a storm of artificial light. As experiments continued across the UK, Russia, the US, Japan, South Korea, China, it became clear no one could do this alone. And so, one of the largest scientific collaborations in human history began. ITER, the International Thermonuclear Experimental Reactor, built in southern France, developed by 35 countries, including former political rivals. ITER is where humanity gathers to try to create a star. If successful, ITER will sustain self-sufficient fusion reactions, generating more energy than it consumes. With no carbon emissions, no long-lived radioactive waste, a miniature sun safely on Earth. Alongside ITER, another path emerged: laser-based fusion. At the National Ignition Facility, NIF in the US, 192 of the world's most powerful lasers focus on a fuel pellet smaller than a corn kernel. In an instant, pressure and heat reach star-like levels. And in December 2022, they announced a breakthrough. For the first time, they produced more energy than was put in. The fusion ignited. There are still challenges: conversion, stability, safety. But the door has opened. Light is no longer something we just observe. It's something we can create. Strangely, for billions of years, stars burned silently, unseen. Now humanity, after centuries of watching, has recreated the universe's past in a lab, on a small planet, in a quiet room. Not to incinerate, but to nurture. Not to become gods, but to understand that, though small, we hold the power to simulate the cosmos. One day our cities may be lit by fusion, cleaner air, clearer skies, and in every light bulb, every meal cooked by that energy, we'll remember. This is the light of a star, and the light we made ourselves. There is something special in the history of humankind. From very early on, long before we understood what stars truly were, people assigned them meaning. No one had ever touched a star. No one had ever heard its voice. And yet, across every civilization, from prehistoric times to the modern world, human beings placed a strange kind of faith in those glowing points in the sky. That they watched, that they guided, that they knew. To the ancient Egyptians, the star Sirius was not just a point of light, it was the embodiment of the goddess Sopdet, the harbinger of the Nile flood season. All of society revolved around the appearance of that star. Calendars, taxes, rituals, harvests, funerals, everything tied to the cycle of that light. Thus, Sirius didn't just measure time, it measured trust. The Greeks, with their sharp philosophical minds, were no less entranced by the stars. Plato believed the universe operated through ideal forms, and the motion of the stars was proof of a perfect cosmic order. Aristotle claimed that while all things on Earth changed, the starry heavens were immutable, made of a divine substance called ether, different from earth, water, fire, and air. They believed the sky was the embodiment of perfection, and all moral striving was an attempt to reflect some small piece of that perfection. By the Middle Ages, Christianity carried this view further with the concept of heaven, a realm above the celestial spheres, where good souls would be guided after leaving the mortal world. Renaissance artists painted heavens full of stars, light piercing the clouds, angels soaring between constellations, like a higher layer of reality. The Bible speaks of stars often as symbols. He counts the number of the stars and calls them each by name. The light of the righteous shines like the stars forever. To them, starlight was a promise, a divine gaze, a reward for virtue. In Islam, scholars like al-Biruni and al-Tusi not only use stars to orient toward Mecca, but also believed that the order of the heavens reflected moral harmony, that to live rightly was to move in step with that sacred order. In Judaism, God's promise to Abraham was, "I will make your descendants as numerous as the stars in the sky." Starlight became a metaphor for life, for legacy, and for being chosen. Even beyond organised religion, indigenous cultures, from Aboriginal Australians to the Navajo people, wove moral stories into the stars. A dark patch in the Milky Way might be the resting place of ancestral spirits. A constellation might represent a fox, a serpent, or a hero who sacrificed for their people. Each time a star rose, it wasn't just a phenomenon. It was a reminder to live in a way worthy of those who came before. And in literature, that same reverence echoes on. When a character dies, we say, "He became a star." When someone does what's right, we write, "The light within them outshone the stars." When humanity faces darkness, poets say, "Remember the stars, they never forget us." For thousands of years, starlight has illuminated not just our eyes, but our choices. Even today, in our modern world, where we can analyse stellar spectra, determine chemical composition, predict age and mass, that light is still trusted as a symbol. You look to the North Star to find your way. You wish on a shooting star. You tattoo a star on your skin to remind yourself not to get lost. You tell your child, "You are our light, our little star in the great universe." And this speaks to something deeper than any law of physics. Stars do not need to understand morality, but they inspire us to live more morally, not because we are forced, but because in that light there is something ancient, quiet, yet undeniably right. Something that reminds us, be honest like the light, be patient like the orbits. Never give up, no matter how long the night. And if you must disappear, then disappear in brilliance, like the final blaze of a star. For millions of years, life existed in only one place, Earth, a small blue planet, orbiting an ordinary star, on the edge of an ordinary galaxy, in an unimaginably vast universe. We once thought we were the centre, then we learned we were not. But a greater question remained. If life appeared here, could it appear elsewhere? And if so, why? Ancient people believed the stars were the realms of gods. Modern people believe they may be places where life can arise. This shift didn't diminish the stars' magnificence. It simply moved the wonder from myth to experiment. We no longer just pray when we look up. We begin to search, not to confirm our loneliness, but to understand. Is life inevitable? Or is it a rare miracle? That question gave birth to a new field, astrobiology. This science doesn't search for aliens with antennas. It asks, what creates life? And do stars play a role in that? From simple molecules like amino acids to complex structures like DNA, astrobiology traces the conditions that could spark biochemical reactions. Not just in a lab, but within cosmic dust clouds, on distant planetary surfaces, or in subsurface oceans beneath icy crusts. Voyager carries greetings for unknown civilizations. Kepler hunts for potentially habitable exoplanets. Second Earths. The James Webb Space Telescope peers into the atmospheres of planets hundreds of light years away, searching for signs of water, oxygen, methane, clues that we may not be alone. And as we find pieces, from carbon stars, from atmospheric readings, from background radiation, we begin to understand. Stars do more than shine on life. They might create it. Carbon, the backbone of biology, came from nowhere else but dead stars. When a massive star explodes, it hurls heavy atoms like carbon, oxygen, and iron into space. Those fragments clump together to form planets, oceans, cells, and eventually us. So we don't just live under the stars, we are made from them. Carl Sagan once said, "We are star stuff contemplating the stars, a fragment of meteorite wondering about its origin, a whirlwind of dust learning to love, to doubt, a carbon molecule looking up and calling it home. But what if life isn't special? What if, wherever there's water, energy, and organic molecules, there is life? Then what does life mean? This is where science meets philosophy. When you know you're the descendant of fusion reactions in stellar cores, when you know your planet formed from ancient collisions of dust and ice, when you know every atom in your body once belonged to a dead star, life is no longer an accident. It becomes a pattern, a replicable one, but it only repeats itself when the conditions are just right. And if those conditions are rare, then life is infinitely precious. Whether or not life exists out there, the greatest miracle is still this: that humanity, a tiny species, once asked the question, once looked up at the stars and saw not just light, but a reflection of themselves. So life doesn't just need oxygen or water, it needs meaning. And the stars, though unaware that we watch them, keep burning in the dark, like unanswered questions still worth asking. Chapter 7. When humanity began to contemplate the death of the entire sky. When you look up at the night sky, the first thing you see is light. The light of stars, of galaxies. Light from flames billions of years old, still travelling silently toward you. But what few notice is this: each point of light is a debt, a portion of energy being spent, a final act of burning. Stars are not immortal. They are born, they grow, and they die. But more frightening is this: not only can individual stars die, the entire universe is destined for a collective death. That idea, though it may sound sorrowful, is not a tragedy. It is a physical reality, a mathematical prediction. And for the first time in history, humanity has begun to consider the death of light itself. The theory of the universe's death doesn't come from intuition, it comes from expansion. Since the universe's birth, it has been expanding, galaxies moving away from one another, not because they're flying off, but because the very space between them is stretching. Like dots on an inflating balloon. None move on their own, yet the distance between them grows. And the important part, this expansion isn't slowing down. It's accelerating. That acceleration, called dark energy, leads to a haunting and elegant hypothesis. The universe won't end in a collapse, but in a slow fading, a cold death, not with a bang, but with perfect silence. It's called heat death, or the big freeze. In this model, the universe continues to expand indefinitely. Stars one by one exhaust their fuel. No new stars are born. Galaxies dim, then dissolve. Each point of light you see today will vanish from view, not because it stops shining, but because the space between grows too vast for its light to reach us. The universe will grow colder, emptier, darker, until nothing is left to burn, nothing to react, nothing to measure. In the trillions upon trillions of years ahead, stars will die, leaving behind white dwarfs, neutron stars, and black holes. Planets will drift, lightless, without suns, without hope. Even black holes will evaporate through a process called Hawking radiation, fading into nothing. And then what remains of the universe will be cold photons, lonely atoms, a temperature approaching absolute zero, where no contrast exists, no information remains, and time itself loses meaning. Not darkness, but a state of eternal stillness. Some may ask, then what is the point of it all? The stars, the planets, life, love, death, if in the end it all vanishes. But that is not a question of physics. It is a question of meaning. Because the reverse is also true. It is because the universe will die that every moment of light still alive becomes infinitely precious. Right now you live in a radiant universe. There are trillions upon trillions of stars burning. Galaxies spiral like brushstrokes across the void. There are planets with water, with light, with life. You are alive in a rare moment. When light still exists, in a timeline so vast that the death of all things is certain, but the life of now is a miracle. When humanity thinks of the death of the entire sky, they do not despair. They fall silent. And then they understand. Nothing lives forever. But light, in the moment it exists, is what gives the universe its meaning. Once you know the universe will die, not by fire, but by cold. Not in a moment, but through a slow fading stretched over trillions upon trillions of years. The question is no longer why. It becomes, can we do anything about it? And while reason says we cannot, imagination whispers, we must try. Even in the darkest room, where light fades slowly, humans still think about escape routes. Theoretical physicists begin to sketch exits. Narrow loopholes in the laws of nature, fragile possibilities. Not guaranteed to work, but just enough to keep the flame of hope alive. Idea 1. Live inside an eternal computer. If matter decays and energy runs out, biological bodies can't survive. But what if consciousness could be preserved? What if the entire mind, memory, personality, intelligence could exist as data? Thus emerged the concept of mind uploading, or more broadly civilization uploading, the transfer of an entire civilization into a machine, not an ordinary computer, but a quantum computer, ultra small, ultra efficient, functioning in the super cold environment that will become common as the universe cools. If designed efficiently enough, a virtual mind could endure for billions of years using just a few photons, looping through thoughts, simulating universes, remembering poetry, and waiting. It doesn't live, in the biological sense, but it doesn't die either. Idea 2. Escape the universe. Jump into another Big Bang. Some physics models suggest our universe is not alone. There may be a multiverse, an ensemble of parallel universes, each with different physical constants, being born, expanding, and dying independently. If so, could we create a tunnel, a path, to leap into a younger, fresher universe? This leads to the theory of wormholes, tunnels in space-time, like bridges linking two distant points across space-time, perhaps with enough negative energy, a substance never yet found. We could hold one open long enough to pass through. It sounds like science fiction, but it's not forbidden by current physics, only by resources and imagination. Idea 3. Delay cosmic death by living extremely slowly. If energy becomes ever scarcer, then the only way to survive indefinitely is to use as little as possible. This idea, called the Dyson hibernation hypothesis, proposes that a sufficiently advanced civilization might live in ultra-short bursts, then enter hibernation for millions of years, using the tiniest amounts of energy to preserve memory, intellect, and culture. Like a candle burning 1 second at a time. Not fast, not expanding, just enduring. Idea 4. Recreate the Big Bang. Launch a new universe. If the universe dies due to heat, disorder, and lack of contrast, then the only way to bring it back is to start over. One hypothesis suggests that if you compress enough matter and energy into a tiny point, it might trigger another explosion. A new Big Bang. The old universe ends. A new one begins. And if humanity survives long enough, perhaps we could cross into that new universe as a legacy. No one knows if that's possible. But mathematically, the equations allow it. All these ideas are fragile. None are certain. We may never achieve them. But just as our ancestors once looked up at stars and imagined gods, today, as we look at dying stars, we imagine ways to outlive them. And the strange, beautiful truth is this: that idea, whether right or wrong, is itself proof of life. No other species has ever pondered the death of the universe. None has ever drafted blueprints to escape it. Only humans. Only us. Temporary, small, fleeting. Dare to plan for eternity. Not because we believe we are immortal, but because we believe light shouldn't fade in vain. One night, far into the future, the last star will disappear. Not in brilliance, not in thunder, not with a sound. Simply silence. That light burned for billions of years, travelled millions of light years to reach somewhere in the universe. Perhaps that place no longer has any observer, no more beings who see, no more minds to think. And then for the first time since the universe began, the sky becomes empty. No more stars, no more Milky Way curling like the veins of the night. No more constellations the ancients once connected into the faces of gods, beasts and fallen heroes. Nothing left to look up to, and no one left to look. The question is, what remains? Some say nothing. When there is no more energy, no more intelligence, no more life, then everything, meaning, love, beauty, fades as well. An absolute end, silent, cold, as final as a period at the end of a sentence. But others say, not so. Because even when the light goes out, what it once illuminated still exists. In memory, in story, in the effort to record, not in matter, not in wave or particle, but in idea, in the brightest age of stars, the one you are living in. Someone wrote down the journey of light as you are reading now. And that act alone, the act of remembering, is already a quiet rebellion against the end. When you tell someone about the stars, when you show your child the North Star for the first time, when you hold the image of a shooting star and make a wish, you are doing something that may seem useless, but it is the only thing that resists the death of the universe. You remember. You speak. You carry on. Suppose one day the light truly fades. No life remains. No mind exists. Then in the last moment someone ever knew of the stars, something was fulfilled. A circle closed. A breath released. A final gaze filled with understanding. And that is not complete death. It is a conclusion. As if the universe, in its journey across 13 billion years, once had a moment when it could look back upon itself, not through a mirror, but through the eyes of a tiny creature called human. Brief, fragile, but smart enough to ask, why? Curious enough to measure, and brave enough to face the end, yet live as if the light would never die. And the last thing left, well, when all else has fallen away, may not be matter, not energy, not information, but a feeling. We were here. We once looked up at the sky, and we told the story. Chapter 8. When the stars become memory. There is something strange about the way humans remember. Memory doesn't need the thing to still exist. Memory can outlive the object itself. And sometimes memory proves more enduring than any form of matter. The stars, once burning bright in the night sky, will one day go dark, but they will continue to live on, not in space, but in the minds of those who once looked upon them. If a shooting star falls through the night and no one sees it, does it still exist? The answer is unclear, but if someone tells the story of the streak of light crossing the sky, of the wish whispered in silence, of the slight trembling in the chest upon witnessing something so wondrous and fleeting, then that star still remains. Not in the sky, but in the heart, and then in a story, and then in a lullaby, and then in a tiny tattoo on someone's wrist. That's when stars become memory. The first memories of stars may have been charcoal drawings on cave walls, in Lascaux, Chauvet, Altamira, sites where prehistoric humans left their marks. There are evenly spaced dots, forming shapes resembling constellations. Perhaps they depicted the Pleiades, the Seven Sisters, a small, soft cluster of stars, often seen at the start of winter. We don't know what the artists were thinking, but clearly even before writing existed, humans wanted to record the stars. by any means they could, not to capture details, but to preserve feeling. The feeling of looking upward and realizing one's smallness. The feeling that the sky is not a ceiling, but a mysterious map. The feeling that those dots of light meant something, even if we didn't yet know what. Then with the advent of writing, stars began appearing in poems, in songs, in scriptures, in love letters, in journals. The Babylonians wrote of stars as tools to measure fate. The Egyptians carved stars on coffins to guard the soul. The Chinese assigned each star to a celestial court official. The Japanese called stars hoshi, the same word for hope. The Latin word stella became the root for stellar, constellation, interstellar. And across all languages, the word star always carries a sense of distance, beauty, and the unreachable. Stars entered human language as a way to talk about things too large to explain. Your eyes shine like stars. Fate is written in the stars. You're the star of my life. When someone dies, they become a star. Follow the guiding star. Simple phrases, but if you listen closely, you'll hear humans use stars to speak of things beyond themselves. Love, destiny, loss, hope. So even if light fades, even if physics dissolves, even if the sky turns to darkness, language still holds onto starlight as memory. It's not just in words, there are lullabies passed down from generation to generation. Eyes asleep, stars rise above. Mother's hand in the wind, rocking you with love. In the high mountains, an old woman hums beside a charcoal stove, her voice thin as smoke. No one knows where she learned the song. No one ever wrote it down. But the lyrics still mention stars as something intimate, sacred, and eternal. And then in the dark, the child sleeps, unaware of why they dream, only knowing something is sparkling deep in the mind, a light not seen with eyes, but inherited from someone else's memory. In visual culture, stars are everywhere. Flags of many nations have stars. School uniforms carry star emblems. Clothes, blankets, scarves, jewellery, adorned with stars. In Hollywood, stars are celebrities. Even the way we use star to describe people. Saying they shine, saying they fall when they fail, saying they light the way, shows that stars have become a form of collective memory. No one sees all the stars, no one remembers every name, but everyone remembers how stars made them feel. And that feeling, passed down over thousands of years, becomes part of humanity's memory. In ancient rituals, when words failed to comfort the grieving, people would say, "You will live among the stars." No one believed it literally. It was a form of remembrance, not to claim the person still existed in the sky, but to give our grief a place to rest. It's how we turn pain into light, how we make something untouchable, like the stars, into a home for the things we refuse to lose. Even in science, where numbers reign, we still find emotional memories of stars. A child reads Carl Sagan and decides to study astrophysics. A couple visits an old observatory where they first held hands. An elderly person looks at a photo of the Milky Way from their youth, knowing the sky will never look that way again. Due to light pollution, due to age, due to time. Memory doesn't reside in the stars. It lives in how we once lived beneath them. And if one day, as predicted, the light truly fades, no stars burning, no one left to witness, no minds left to name them, then the fact that memory once existed is itself a form of life. Because once we looked up, once we told the story, once light was part of the tale. And the tale continues not with light but with words. In an old astronomy book, handwritten and yellowed with age, there is a line, "Stars fade, but memory does not. Memory is not light, but it is the one thing that remains when light is gone." That is the part physics cannot explain. But history preserves, because history, in the end, is the collective memory of what once burned brightly. And if you are reading this now or hearing someone tell it, remember, you are not reading about the stars. You are keeping their memory. No one can take that from you. Not time, not expansion, not the cold death of the universe. Because when stars become memory, they become eternal. Memory is a fragile thing. It fades over time, slips away from individual minds. But humans, as a kind of instinctual reflex, refuse to let memory exist only in the mind. They want to preserve it, copy it, recreate it, relive it. And that's when technology, art, and dreams, three seemingly separate realms, begin to converge for a single purpose: to simulate lost light. It all started simply: a painting of the Milky Way, a star map printed on paper, a sparkling star globe hanging from a child's ceiling, a poster of the Orion constellation behind the sofa. Everyone has seen the stars, but everyone wants to keep a piece of them, through images, symbols, models. And so every simulation becomes a kind of shared personal memory, not identical, not perfectly accurate, but filled with emotion. As computers advanced, star memories entered the digital realm. From Hubble's black and white images to 3D simulations in software like Stellarium, Universe Sandbox, Celestia. Now a child can fly through star systems millions of light years away, touch the virtual surface of Betelgeuse, spin galaxies from their own perspective. Those stars aren't real, but the feeling is, and that's enough. Some artists spend their lives installing LEDs in church ceilings to recreate the night sky. Others convert star spectrum data into sound, a cosmic symphony you can actually hear. Filmmakers use CGI to recreate supernovae and place a silent person watching them, a monument to the unreachable. No one claims these are real stars, but everyone calls them my stars. Because in simulation, we don't seek truth. We seek resonance. An architecture student crafts a star dome from ceramic and etches their late mother's name inside. A fashion designer uses star maps as embroidery on a wedding dress. So on her first night, the bride carries the universe. A gamer builds an imaginary planet in a game, where the sky never changes, and each constellation holds a story only he knows. Gradually, memory stops being the past. It becomes the material of the present, a place where humans recreate light, in their own way. As virtual reality develops, stars are no longer confined to ceilings, screens, or paper. People can walk into a virtual field, lie beneath a star-filled sky, hear wind rustling through grass, smell the earth, and choose a night from 1200 BCE in ancient Babylon. That space doesn't exist, but the feeling inside it isn't fake. And in a world increasingly crowded and bright, where it's hard to see real stars, that simulated sky becomes the final sanctuary of memory. Even artificial intelligence is part of this. People feed AI millions of poems about stars, then ask it to write a new one that feels like a star just went out. The result isn't perfect, but there's something gentle in it. I once burned for you to see. Now I am silent in the stream of forgetting. But do not mourn. You saw me, and that is enough. A poem written by a machine, but drawn from the collective memory of humanity it was trained on. Even machines can't escape the pull of stars. Though they don't know what light is, have no eyes, no heart. Yet they learn how to remember. And in dreams the stars return. No need for science or visuals. Just a feeling of having flown through them, lying among them, melting into them, or being shown the sky by someone who says, "Look, that one is your star." No one verifies facts in dreams. Only the emotion remains. And that too is a kind of memory. As real as any data. Stars may no longer dominate the sky like they once did, but they fill the world inside us, preserved through brushstrokes, cameras, code, digital sound, semiconductors, neurons, dreams, whispers. And that ensures they never truly disappear. If one day the real sky goes entirely dark, the simulated sky will still shine. Not because of accuracy, but because of meaning. No one thinks the star tattoo on their wrist is an actual celestial body, but it recalls someone's eyes, a certain night, a moment of looking up, something lost, but never forgotten. Memory, art, technology, dreams, all are humanity's attempts to preserve what has passed. And when applied to the stars, it becomes one of our greatest achievements without needing a single material, the immortality of light in the human mind. Imagine a world without stars, no light, no night sky, no North Star to guide the way, no Milky Way stretched across like a spill of milk. Above there is only endless black, or worse, complete invisibility, a space where there is nothing left to see. You might think, then all memories will fade too. But strangely, the opposite happens. The more absent the stars become, the more deeply they are remembered. The less they can be seen, the more humans recreate them. Not with their eyes, but with memory. Not to see, but to keep. And then something happens. Memory is no longer a substitute. It becomes the thing itself. In the past, the stars were the source. Memory was the reflection. But when the stars vanish, the reflection becomes the origin. The inner sky begins to replace the outer one. On the dome of an abandoned church, an artist paints the Cassiopeia constellation using artificial light. Beneath the dome, no one can tell what is real and what is painted. But that no longer matters. Because when a child looks up and asks, "What star is that, Mummy?" the answer is enough. That answer is the star. A couple holds their wedding in a virtual planetarium. The ceiling simulates the exact night sky from when they first met. Not a single star is real, but the emotion is. And after that night, whenever they think of the sky, they think of the one they created, not up above, but within each other. In the last functioning digital archive, on an energy-depleted planet, an artificial intelligence scans billions of gigabytes of astronomical data. It reconstructs models of every star that ever existed, each light, each motion, each death, every streak that crossed the universe, every star map from the years 2043, 5012, 13228. No one looks at them anymore, but the model still runs, silently, because the very act of remembering is light, not to serve anyone, not to illuminate anything, just to be. A child in the future reads an old book. On the first page it says, "When we had the sky, we called it eternity. When we lost the sky, we called it memory. But in truth, only one thing lasts: what we choose to keep." The child has never seen stars, but the image in the book and the emotion it carries makes them believe, "I've seen them." And so the star exists, not in the sky, but within them. The world continues to live under a dead sky, but in homes, in machines, in paintings, in dreams, in stories passed through generations. The sky still exists, not merely as memory, but as a parallel reality. There is a hypothesis, not in physics, but in philosophy, that says a thing becomes real when no one can tell the difference between remembering and seeing. And if that's true, then the stars exist now more than ever. No limit of distance, no need for light to travel across years, only the condition that emotion still lives. When memory has fully reimagined, when simulation is no longer a tool, but a home, when every upward glance is a gaze inward, then stars are no longer celestial bodies. They are concepts, symbols, mirrors, us. We don't need light. We are light. And when the entire sky outside holds nothing, we sit down, close our eyes, and in the darkness behind our lids, a small light remains. Not clear, not fixed, but enough to know we never lost it, because it was never the skies to begin with. Chapter 9. When the history of the stars becomes the history of ourselves. In every civilization, there are stories not written to be remembered. but written so they are never forgotten. The story of the stars is one of those stories, not because the stars are important, but because the way we look at them tells us who we are. From the first carvings on stone, to telescopes the size of buildings, to virtual maps that children of the future can touch, every advancement in the history of stars has mirrored the history of humanity itself. We once thought the stars were unchanging. They were there, and we changed. But now we understand. The way we see the stars changes with how we see ourselves. When we were nomadic tribes, the stars were calendars, compasses, sacred things. When we built cities and walls, stars became maps of empires, of wars, of myths. When we explored science, stars became nuclear reactions, hydrogen clouds, data points. But in every era, the stars remained a mirror, and the image inside was always us. Let's look back at a timeline of moments. When humans first looked up and named a constellation, that was the first time we assigned meaning to the universe. When we traced the orbits of Venus and Mars, and realised Earth was just one planet among many, that was the first time we knew we were not the centre. When we built telescopes and discovered distant galaxies, supernovae, black holes, that was the first time we knew the universe was larger than our imagination. When we accepted that all stars will die, all light will fade, that was when we understood that everything, even us, is finite. And when we still told the story of light, even as darkness approached, that was when we became the light. The story of the stars is not about astronomy. It is the emotional diary of a species that knows it is small and still chooses to look up. This story contains poetry and equations, fairy tales and source code, lullabies and farewells, dreams no one remembers, and images stored by machines long after humans are gone. It is no longer about the sky. It is our history, told through the image of stars. There's a strange pattern in human history. Every time we reach outward, to explore, to journey, to discover, we always look up. Not because something is waiting there, but because something there reminds us. Looking up is the simplest act, but also the deepest. It is the beginning of a question. What are we in the face of the infinite? And also the answer, we are the only beings who have ever asked. Now, when we look back at the full history of the stars, from the dawn of time to the end, from real light to simulation, from reality to memory, from data to symbol, what do we see? We see a journey that repeats but never in vain. Each generation sees stars differently. Each culture names them uniquely. Each individual holds a star of their own. And in these differences, history is preserved, not to be frozen, but to stay alive. There is an old poem, its origins uncertain. Perhaps from Greece or ancient China, some passed down orally through the centuries. The last person to write it down died long ago, but the record remains and it reads, "When I die, do not lay me in the ground. Do not scatter my ashes at sea, but bury me in the memory of a star. If someone looks up and remembers its name, I live." A simple poem, no basis in physics, no metaphysical promises. But it carries a feeling, and that feeling is the final thing left when the light has disappeared. No one lives forever. No civilization lasts eternally. No memory remains intact. And no light continues to shine endlessly. But even when everything must fade, there is one single act that resists disappearance: to tell the story. Since the dawn of time, humans have told stories. Before writing, we carved images. Before images, we sang. Before sound was, we pointed to the sky and whispered. That is the star of our ancestor. We spoke of the stars not just to understand the universe, but to preserve the human part of ourselves within the unknowable. When history began, chroniclers started recording celestial events. Which eclipse coincided with which king's death? Which comet appeared before a great plague? Which new star was first documented in the observatories of Baghdad or Beijing? But what matters is not the data, it's that the act of recording itself is an expression of collective memory. And in those records, the stars were evidence that we had lived, had seen, had remembered. A 17th century astronomer once wrote in his diary, "I saw this star tonight, and I know Wasin, when I am gone, its light will still reach Earth. But if no one records it, it's as if that light never came." That line with him on a page yellowed with age is a quiet reminder. We don't record to archive. We record to exist. When YouTube emerged, when podcasts grew, when audio and video tools became available to all, the task of preserving the history of stars no longer belonged only to scholars. It belonged to everyone. A 12-year-old girl creates a video about her favourite constellations. An elderly man builds a model of the solar system out of tin cans and shares it online. A YouTube channel streams the night sky live from Chile. And thousands watch in silence as if attending a memorial. Each of these small acts is a way for humans to hold on, in a universe drifting ever farther away. Because when we tell the story, we're not just describing starlight. We're trying to draw ourselves closer to that light. We're trying to say, I saw it, I remember, I'm holding on to it. Even if the star has gone out. Even if no one can confirm it anymore. Because as long as someone tells the story, some part of the star still lives. On Earth, city lights have erased the real sky. But in our minds and digital memories, the sky continues to be told. Again and again. Some stories are pure imagination. Some are stitched from mythology, emotion, or even mistakes. But that's okay, because the purpose of storytelling is not to be correct. It is to preserve the light, to preserve the feeling, to preserve existence, to preserve the whisper of a species that knows it will die, but still speaks of things beyond death. A documentary filmmaker once said, "I don't make films about stars because I'm an astronomer. I make them because I once sat with my father under the sky in 1995, and he pointed up and said, 'Do you see Cygnus?' And in that moment I felt like the universe understood me, so I tell the story, because he is gone. And that star might go out too, but I'm not ready to lose them both." The story of the stars, then, has never been only about the universe. It is how humans tell the story of themselves, by speaking of something they could never touch, but once saw. And so, when you listen, or read, or watch, or tell someone, long ago people used to see the stars, you are not speaking of the past, you are keeping the light from going out. There is a moment when everything ends, not because someone wills it, not because anyone commands it, but simply because time has run its course. And in the universe, every road found in, no matter how long, has a final bend. So does light. No stars remain burning. No beams of light still travel. No observatories remain functioning. No human eyes left to look up. No voices telling. No maps, no simulations. Only a perfect emptiness. A silence deeper than all silence. A darkness with no reflection. In that emptiness you hear nothing. You see nothing. You record nothing. And yet somehow something still remains. Not within physics, not of quantum fields, not proven by equations. It lies in the idea that something once was. There once was light. There once were stars. There once were people living, breathing, loving, crying, who looked up. There once was a planet where a child asked, "What's that star called?" And someone, a mother, a father, a friend, a stranger, smiled and told the story. The light has gone out. But that moment, even if no one remembers it clearly, still exists. Because once something has happened, it cannot unhappen. Existence does not need repetition to be real. It only needs to have been. And when the universe enters its total stillness, What remains is its memory of itself, not in sound, but in the sensation that lingers, like the scent of smoke after the fire is gone, like the afterimage of a glance when the eyes are closed, like a story you no longer tell, but still remember the first line. There is a hypothesis, vague and unfounded, that when the last light recedes, the universe does not die. It closes its eyes, not to sleep, but to dream of everything that once burned, once flew, once shone in the thick of darkness, once was seen, once was told. And in that dream, lasting who knows how long, the stars still exist, no longer as dots in the sky, no longer as nuclear fusion, no longer as data. They are thought, story, the last thing the universe refuses to let go of. Not because it's needed, not because it's useful, but because it is beautiful. In a piece of speculative code, someone once wrote, Sao chep chin sua if, last star dot out. True, remember. A simple line of code. When the last star goes out, the final function is not to recreate, not to restore, not to survive, but simply to remember. We told this story not to cling to the light, not to conquer death, not to prove anything. We told it because it is the only way for the light not to disappear entirely. When someone listens, when someone continues the telling, when someone sits in the dark and thinks, I remember seeing, then that light still remains, not out there, but within the one remembering. And if anything is left after all layers of light, all spans of time, all forms of matter, it is not a star, not data, not image. It is the will to tell. A whisper, more fragile than any form of being, yet stronger than all gravity. I once saw a star. That is the final line in the history of the stars. There is nothing more after that. There doesn't need to be, because in that one sentence, the light was kept. The end. The history of the stars is complete. On the night field and the ancient starlight, no one knows exactly when humans first looked up to the night sky in search of shimmering lights. Perhaps it was a child sitting beside a campfire, eyes squinting from smoke, still trying to peer through the distance to glimpse those glittering dots. Or maybe it was an old man, hunched with age, silver hair falling to his shoulders, pausing in a field to watch the streak of a falling star and silently wishing, if only I could touch it. Tonight a gentle autumn breeze lulls the tiny blades of grass, forming soft waves across the field. The sky stretches wide, drawing back its dark curtains studded with diamonds. Amid that vast expanse, how many stories are waiting to be told? How many souls have been captured in the light that took 1,000 years to reach us? The whisper of a child's eyes. The very first moment she opened her eyes, Lynn saw the brilliant night sky before her. Just 9 years old, a small figure in a faded floral dress, she stood amidst a field of tall reeds. Her round eyes, clear as crystal, seemed to reflect the entire universe. Chi-Lin, look! A shooting star! She cried out, pointing to a streak of light cutting through the darkness. Her voice rang through the deep silence, echoing off the distant tree line. Her older sister, Mai, smiled gently. Keep it down, Lynn. Don't wake Grandpa. But her eyes, too, were locked onto the glowing trail, lips parting as if to whisper a wish of her own. Lynn stepped forward, feet brushing the gnarled roots of bamboo, and clutched the old telescope her grandfather had just given her. He said this belonged to an astronomer. If I look through it, I'll see... She paused, gazing skyward. The black clouds fanned out above like a giant stage curtain, edged in pale white, holding countless golden stars within. She pressed the telescope to her eye, staring into the heavens. Her eyes sparkled. Chi, do you see them? There are planets too. Mai leaned over, peeking through the scope. She gasped, then giggled. Really? Where's the moon? But tonight there was no moon, only stars and tiny specks of light. And so the sisters took turns peering, sighing with awe. Before them stretched infinity. Far away floated the massive gaseous wheels called Jupiter, Saturn, Uranus. Each golden, white or grey dot held stories untold for millennia. Lynn gently exhaled and traced circles in the air. "This is Mars and here's Jupiter," she giggled, her voice as sweet as sugarcane. Quietly, following the pulse of the cosmos. After putting the telescope back into her coat pocket, Lynn saw Grandpa approaching. Grandma handed him an oil lamp and folded up the dew-soaked mat. He set a low rattan chair under the bamboo and beckoned the girls to sit in his lap. "Long ago," he began, eyes cast toward the sky, "people called the heavens an endless library. Each star, a book. Each falling star, a page turned. Never to be read again." His voice flowed slow and warm, like a heartbeat. Lynn and Mai listened, as if hearing the wind pour from his lips. He continued, "When Babylonian astronomers observed the stars, they didn't just draw maps. They recorded every motion, every position, every faint flicker. They believed the stars were gods. Stars decided harvests, jewels, fates. In Egypt, they placed holy scriptures on the pyramids so that Sirius might guide the soul's journey." His words faltered with emotion, like verses drifting in rhythm. Suddenly, a sharp streak blazed across the sky. The girls gasped again. Grandpa smiled, eyes brimming. "That wasn't a shooting star," he said softly. "That was a meteorite. A shard from the very beginning of the universe. Centuries of memory packed into a single moment, between night dew and chirping crickets." Lynn looked at her grandfather, fingers curling into the folds of his coat. She began to understand. The sky wasn't just scenery. It was teacher, ancestor, the eternal flow of time, when the stars begin telling their own story. Time slipped by, and the night field was left with nothing but the humming chorus of insects. The sky lay still, glowing faintly with stardust resting on its cloud-draped canvas. Grandpa helped Grandma inside. The girls turned to follow, but Lynn paused, glancing back one last time. She saw someone standing at the edge of the path, a faint silhouette, back turned to the sky, wearing a long grey cloak, a wide-brimmed hat, holding a rolled parchment in their hands. Startled, Lynn froze. Then, as if pulled by something, she stepped forward. "Hello," she whispered. The figure didn't turn. A breeze stirred, and, swish, a piece of parchment slipped to the ground. Lynn picked it up. On it, in fine handwriting, read, "I am the storyteller of stars. I am here to listen and record. When no one looks up anymore, I will leave." Lynn blinked, stunned. She ran to ask Mai, but Mai shook her head. There was no one there. Lynn looked at the parchment, Grandpa's stories echoing in her mind. She smiled softly. "Then I guess I'll be the one who keeps telling the story." She clutched the parchment close to her chest and ran inside, tears glistening. Not from fear, but from the sense of receiving a sacred mission. When stars still shine, the storyteller follows light. When stars are gone, the storyteller becomes the light. A song wrapped around the starlight. From that night on, Lynn began to write. Her letters were shaky but steady. She recounted the first shooting star, the story of Babylon, the mysterious parchment, her grandfather's wisdom. She drew star charts on the wooden attic walls, sketching Orion, Pisces, Taurus in coloured chalk. Each evening she sat by the window, telescope by her side, pen in hand, whispering, "That blue star awakens a longing in me." The verse was unfinished, but Lynn knew its echo would spread. Grandma tucked her in gently, murmuring, "Sleep now, dear. Tomorrow I'll tell you more." Lynn nodded, smiling with closed eyes. In her dreams, she and Grandpa rode the back of a star, gliding through galaxies, visiting crystal gardens and sapphire lakes on distant planets. A new dawn on the horizon. The journey of telling star stories never ended. Like the ever-expanding universe, stories of stars continued to grow. Lynn grew up, became a storyteller, a writer for magazines, a YouTube creator, even a children's book author across 5 continents. The old telescope was preserved carefully, resting beside her globe and star atlases. One day, returning to the wooden house of her childhood, the oil lamp had long gone out, and the moon glowed bright in the night sky. She picked up the telescope once more and looked up. The sky still had stars, still shimmered with ancient light. She smiled and quickly scribbled a new note. Beneath this sky, we are but small wanderers, but through stories, through memory, we become immortal stars. And so, the story of the stars continued. Not to answer every mystery, but to ensure that light, even the light of a story, never truly goes out.